Hello, this is Rebecca Snyder and welcome back to Math for Technology. In this video we are going to talk about circles, which is section 3.3 in our textbook. So with the idea of circles, think about what do you already know about them. Take a moment and pause the video if you need. Here are some pictures of circles, and so we're going to talk about some of the terms that do go with them. What's important is we have a center, and then we have all of these points, this black curve that's all the way around that center, and all of these points that is on this black curve are the same distance away from the center, and that's what makes a circle. Now that distance that is created between the center and those points is the radius. So the radius is the distance from the center to the circle itself. Now if you doubled that, drew it in both directions, I'm going all the way across the circle, but through the center, that is the diameter. Some other important terms, we have a chord. That simply is any line that goes from should be line segment, that goes from one side of the circle to the other. A special chord that goes through the center is the diameter, right? A chord goes from one side to the other. If that happens to go through the center, then we call it a diameter. Two other lines, but that tend to keep going, that we need to talk about is a tangent. A tangent is a line that touches a circle on the outside at one point. Where it intersects the outside will always create a 90-degree or a right angle with the diameter or the radius. If it's not at a 90-degree angle, it actually will go through the center in two places, and when that occurs, that is called a secant. Now some of the formulas that are used with circles are to find circumference and area. The circumference is the distance all the way around the outside of the circle. So in this case, the circumference would be all of this as I were to go all the way around the outside of the circle. And then the area is if I were to fill it in. Lay some concrete, fill a pool with water, right? The area is that whatever the stuff is that you're laying down, how much it would fill. It could be material or paper or whatever. So we have formulas for doing that. For finding the circumference, if you're given the diameter, you simply take the diameter times pi. If you're given the radius, take the radius times 2, which creates the diameter, and then multiply it by pi. To find the area, if you're given the diameter, you take the diameter and you square it, you multiply it by pi, and you divide it by 4. Now this one is not the most common one that's used for area. You may have in the past from some teacher seen or heard of pi r squared. That is the most common one that's used. So we're going to go ahead and practice using those formulas. In this question, as I read it, find the area and circumference of a circle. This one gives us the radius. We have a radius of 16 centimeters. So we're going to focus on the equations over here on the side, on this one. So for area, I'm going to do pi times 16 squared. When you are doing your calculations, I do prefer you use the pi button. Please do not use 3.14. Use the pi button. So 16 squared times pi is approximately 804.25. Now, here's how I would like you to go about rounding. Look at the problem that's given. So in this case, in the radius, it's going to the nearest tenth. Round your answers one place farther than what's given. So this has to the tenth, so I went to the hundredth. And centimeters, since area is filling in both length and width, or two directions, north and south, however, right, east and west, since it's filling in two dimensions, I always make my label be centimeter squared into squared whatever squared. When I'm doing circumference, the formula with the radius is 2 pi r. So I'm going to go 2 times pi times the radius of 16. Again, I'm going to use the pi button. So I have approximately 100.53 centimeters. Now this one is not squared, and the reason is because what you're essentially doing is you're walking in a single direction. It just happens to curve around and around. So it's a one-dimensional unit, not a two-dimensional unit. So the next question says, if the area of a circle is 576 meters squared, what would be its diameter? So we're asked to be working backwards. So they gave us the area, so I'm either going to use the pi d squared over 4 or the pi r squared. They're asking for the diameter, so since I'm asked for the diameter, I would use the diameter. Since they gave us the area, let's use the pi d squared over 4. So 576 equals pi d squared over 4. So we're going to go ahead and think about what do I have to do to get d by itself. The first thing I'm going to do is multiply by 4. So 576 times 4 is 2304. So now the 4 is gone. Now I have to get the pi out of there. Since it's multiplying with the d squared, I'm going to divide by pi to remove it. Again, I'm going to use the pi button. So I have approximately 733.39 is d squared. Now I have to think about how do I undo a square. So what this is asking is what times itself is this 733 number. To undo that, we square root. That square root symbol takes out the square. Since I did it on the right, I have to do it on the left. So I'm going to square root my previous answer, and I'm going to come up with, I have a diameter of approximately 27.1 meters. The number that they gave me in my question was to the nearest whole number, so I did my answer to the nearest tenth. So this, what they've done is they've taken the circle and they've cut it. They have both a radius and another radius showing, and then they've shaded in the area of the circle between that. What this does is it creates what's called a sector. Whenever I see a sector, I always think of a piece of pie or a piece of cookie or something round, a piece of pizza. Okay? So the sector is all of this that's filled in. Now if I just were to look at the outside edge, so just this piece out here, that is an arc. So the sector is the whole thing, the arc is the outer edge. Now we do have some formulas for helping us find those. If I'm looking for that distance on the outer edge, it's not the entire circumference, it's just a piece of it. Depending on if your angle is given to you in radians or degrees, if it's in radians, you would do the formula S equals theta r. And what theta is representing this angle that is created between the two radii. If the angle is given to you in degrees, then you would do theta over 180 times pi times r. To find the sector, so how much area is in the whole piece of pi, you would do 1/2 r squared theta if they gave you the radius, if the angle is in radians. If they give you your angle in degrees, you would do theta over 360 times pi r squared. So we're using theta to represent the angle, and the reason that happens is a lot of our mathematics was written by the Greeks, and theta is a Greek letter. So number 3 says find the arc length if the radius is 25 and the angle given is 2 pi over 5. So 2 pi over 5 is in radians because it doesn't have a degree symbol, so I'm looking over here on the left. They're asking me for the arc length. Since I'm looking for the arc length, I'm going to use S equals r theta. So I have theta and r. So my arc length is going to be my angle, which is 2 pi over 5 times my radius of 25. So I'm actually going to do some of this math in my head. 5 goes into 25 5 times. 5 times 2 is 10. So in my calculator, I'm just going to do 10 pi. And so pi is 3.14. So if I multiply it by 10, it should be approximately 31.4 and it is an arc length, which is part of a circumference, so it's a linear or a one-dimensional motion, so it's just in centimeters. It's one-dimensional, not linear. But that is the arc length. So in this one, it says find the arc length if r equals 6 centimeters and theta is 45. So this time I'm going to use the arc length given the degrees. So I'm using s equals theta over 180 times pi times r. So my angle that they gave me is 45. I'm going to divide that by 180. I'm going to then multiply it by pi and 6. So 45 divided by 180 times pi times 6. And I'm just plugging it in. I'm not doing it in steps. I this time get an arc length of approximately 4.7 centimeters. So on the outside of a circle, I have about 4.7 centimeters of string or wire or whatever that unit is that I'm going around the outside of the circle. It could be rubber like on a tire. So in this case, they're asking us to find the actual angle if we know that the radius is 40 centimeters and the arc length is 112. So they're asking us to work backwards. Since it didn't tell me what I should do my angle in, it's up to me. I can do it in either degrees or radians. I'm going to go ahead and do it in radians just because the formula is simpler. It's just theta and r. So s is 112. I'm looking for theta. I know r is 40. To get theta by itself, I simply need to divide by 40. That'll remove it, leaving the theta by itself. 112 divided by 40. So my angle in radians, because I use the radian formula, is 2.8 radians. In number 6, they want us to find the radius. If I have an angle of 2 pi over 3, it does not have the degree sign, so this is in radians, and I have an arc length of 18.5 centimeters. Since this is in radians, my angle, I have to make sure I use the angle formula with radians, which is the s equals r theta. So the s is 18.5, theta is 2 pi over 3, and I'm looking for r. Now, depending on what calculator you're using, it might be easier to do this in parts. So I'm actually going to multiply by 3. That will cancel the 3 in the denominator. So 3 times 18.5 is 55.5. I still have a 2 and a pi and an r. Now I'm going to go ahead and divide by 2 pi. Depending on your calculator, you might need to put the 2 pi in parentheses to make sure that it keeps those both in the denominator, making sure you're dividing by both. When you get done, you should get approximately 8.83 centimeters for a radius. If you don't, you need to experiment with your calculator and figure out if you need the parentheses or not. Okay, so now what we want to work with is the area of a sector. So how much material would it take if I needed to fill this in? Or maybe I need a circle with that piece cut out. How much material am I taking out? This question gives us the angle in degrees, so I want to make sure I use the area of a sector in degrees. So I'm going to scroll back up and look. Area of a sector in degrees is theta over 360 times pi r squared. So I'm going to use that formula. Area equals theta over 360 times pi r squared. The angle is 60 over 360 times pi times my radius of 8. So 60 divided by 360 is 1/6. I'm going to times it by pi, and then I'm going to times it by 8 squared. And so my area is approximately 33.5 centimeters. I'm filling in a two-dimensional space, so that is squared. And again, I just plugged all of this into the calculator and did let it do the work for me. This one gives me, I'm asked for the area of the sector, but notice that my angle is in radians. So I'm going to look back up here at my chart. If my angle is in radians, it's 1/2 r squared theta. So I'm going to write it down, 1/2 r squared theta. So my r is my radius, not my radians. So that is 5, and I have to make sure I square it, times my radians, which is 2. So 1/2 of 2 is 1. 1 times 5 squared is 25 centimeters squared. And I realized I have a lot of centimeters. That doesn't mean all problems will be in centimeters. We definitely could have inches or feet or whatever. So if you have any questions, make sure you email me so I can help you out. And that's the end of circles. I'll see you in the next video.